Hello, this is Michael,
This is Ryan.
and this is Lab 11, Detectors.
For part A, we are observing different detectors and their properties. So for part 1 of part A, we set up an APD and PC for the same LED. We covered it with a black cloth and we set it to observe a signal to noise ratio of 1 for our photodiode, and we were still able to detect a clear signal with our APD.
Okay, so for part 2, we used a PIN diode, and we measured both the voltage and current from our PIN diode, detecting an LED as we varied the light level. We found a linear relationship for current and light level, and we found a logarithmic growth relationship for voltage and light level. And this is what we expected to find.
For the next part, we used the same procedure as for the PIN diode, except for our photoconductor, and we found the same linear relationship for current and light level, and the logarithmic relationship for voltage and light level, and again, this is what we expected to find.
In part 4, we used a flash lamp, finding the time constant of a PIN response with and without a resistor attached. Without the resistor attached, we found tau to be 880 microseconds, and with the resistor attached, we found tau to be 100 microseconds. This is as expected since tau is equal to resistance times capacitance, and the resistors then in parallel. Adding the resistor lowers the equivalent resistance and lowers the time constant.
For part B, we are observing properties of infrared imaging. And so first we observed an image through a camera that can detect IR and visible light. And we used white light to illuminate our object first, and we can see the image. And then we added an IR filter, and we are still able to see the image. And then we switched to infrared light to illuminate the object. And with no IR filter, we can see the image. And then when we added the IR filter, we could not see the image. And this is as expected since the IR filter blocks only the infrared light, but not the white light.
For this part of the lab, we used an IL camera, a hot soldering iron as an object, and a focus camera at infinity with a focus on the object through the IL lens. We used the distance between the lens and object as an approximation of focal length. We found the focal length to be about 15 millimeters. Next, using a mirror, we set up to have a magnification of -1, and functions like any other optical system, distance between object and mirror is the same as the object and camera.